In the theory of special relativity, an event, such as the launching of a spacecraft, is a physical happening that occurs at a certain place and time. Here we show a stationary observer on Earth awaiting the launch. To record the event, the observer uses a reference frame that consists of a set of x, y, and z axes called a coordinate system and a clock. Next, an observer flies onto the scene in a plane moving with a constant velocity, meaning both a constant speed and direction. This observer records the event with her own coordinate system, with x', y', and z' axes, and her own clock. Each observer is at rest relative to their own reference frame. However, the Earth-based observer and the airborne observer are moving relative to each other, and so also are their respective reference frames. They therefore record the time and position of the event, which might be the ignition of the engines as seen here, with their own clocks and relative to their own coordinate axes. The theory of special relativity deals with a special kind of reference frame called an inertial reference frame. An inertial reference frame is one in which Newton's law of inertia is valid. That is, if the net force acting on a body is zero, the body either remains at rest or moves at a constant velocity. In other words, the acceleration of such a body is zero when measured in an inertial reference frame. Since the reference frame of the ground-based observer has zero, and therefore constant, velocity, it is an inertial frame. The plane is moving at a non-zero but constant velocity, and is therefore also an inertial frame. An observer on the spacecraft, however, is not in an inertial frame, since the engines are linearly accelerating the craft upward. Frames that undergo circular or curved motion are also accelerating, since their velocity vectors are changing with time. For instance, the observer shown here is not in an inertial frame of reference. With this in mind, Earth-based reference frames are not quite inertial reference frames because they are subjected to centripetal accelerations as the Earth spins on its axis and revolves around the Sun. In most situations, however, the effects of these accelerations are small and we can neglect them. To the extent that the Earth-based reference frame is an inertial frame, so is the plane-based reference frame because the plane moves at a constant velocity relative to the Earth. Inertial reference frames are important in relativity.